Okay, I took a scale. This thing happens to be 14 foot tall. I do it at 28 inches. I put the whales where they go physically to scale. Okay, you got a rule, hopefully you remember this. The top set goes a foot from the top. The bottom set goes a foot from the bottom. Okay, now we're going to use our 27 inches. So I put 27 more. 27, 27, 27. Okay, I want to figure out where that falls. And you can see my scale says, man, that point and that point look pretty close. I don't know if they are exactly. My scale says they look like it. So if I do the math, I take 12 inches and I converted, this is the drawing we had at the beginning, okay? I converted the slope to 4 feet and 10 feet. That's drawn to scale. 10 feet is 120 inches. So I'm going to start working from the top and figure out where this whale is. So if I take 12, add 27 to it, it's up 39 plus 27. 66 plus 27, 93 plus 27, 120 exactly. So that whale is centered right on the break point. And now if I go the rest, I've got 48 inches left, 12 of it used, this is 36. Okay, I could put a whale in between at 27, but look what happens to the pressure. The pressure keeps getting littler and littler and littler. So I really don't need it. So I'm going to leave this at 36 inches. So there's my whales. There's where they're going to be spaced, right there, just like that. And they're spaced good enough to take care of the strength of the 2x4, which is the stud. And now they're there. Now I've got to find the load on the whale. Okay, this is a little bit different for you now. If you look at the picture, the picture I'm playing with is on page 612, okay? Okay, I'd like you to make sure you've got a hold of that. I'm trying to find 611 if I can. Okay, 610, 611, where are you? Okay, 512, 512. You got to be here right here shortly. Okay, I got it. 611. Okay, spacing of whales. Spacing of whales was done. Okay, step 4. Whale size and tie spacing. Okay, let me see. Spacing of whales. 27.4, that's page 611. 612, apart, 4 foot depth. Okay, now what I need to do is I need to determine the wall tie spacing. To do that, I got to know how many pounds per lineal foot each of those whales have. So this is how you do it. You've got the concept before, so it shouldn't be a biggie for you. So what I'm going to do is I'm going to go halfway in between. Halfway in between that whale, and I'm going to draw a line. Halfway in between. 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 Draw a line. Okay, you see those areas. That area right there is carried by that whale. This area in here is carried by that whale. This area, that triangular area, is carried by that one. That goofy shape is carried by that one. So all I need to do is find the areas of each of those shapes, and I have the load per lineal foot carried by the whale. So let's do it. So this is going to be how tall? 12 plus half of 27. 13 and a half plus 12. 13 and a half plus 13 and a half, that's 27. 13 and a half, 27. 13 and a half, 27. So those are nice. Those three are all going to be the same. Now, what do I have here? I've got a mess. Okay? This one's pretty easy, so I'm going to do him. 12 plus half of 36. That's 30. The next one is 13 and a half. So this whole thing right here is 13 and a half plus 18. How much till I hit the break? Okay? Hopefully you can see this number right here is 13 and a half, and this number is 18. Okay, so I'm gonna put a little different color line across there to make it into two shapes. So I need the area of all of those shapes. So let's do it. If I take 25 and a half and divide it by 12, 25.5 divided by 12 multiplied by 600, I get 1275 for the area here. 27 divided by 12 times 600, I get 1350 here. Pounds per foot, 1350. 1350. Okay, I got those. I got two left, and those don't look to be pretty, so I got to screw around with them. Hopefully you can see this number right here isn't too bad to get. It's on my slope. For every foot I drop, the slope is 150 cubic pounds per cubic foot. So I'm dropping 30 inches, which is 2.5 feet. 2.5 times 150 gives me 375 is that value right there. So what's the area of that triangle? Half base times height? It's 2.5 feet tall. It's got a horizontal 375, so 0.5 times 375 times 2.5. 468.75. 68.75. That's that one. Now I've got two areas here. First one's not too bad, 13 and a half divided by 12 times 600. 675 is this bottom. I'll get me something that writes a little better. 675 is the bottom. Okay, the top. I'm going to average the width. 375 plus 600 divided by 2 gives me the average width, and it's 18 inches tall times 18 divided by 12, 731.25. Okay, I'm going to add those two together. Gives me my total. So my total is 731.25 plus 675. 1406.25. 1406.25. This is going to be a pain. Okay, there's my load on each of those sets of whales. Okay, what do I do now? The whale size is dependent on how far apart the wall ties are. If I've got a max of 1,406.25 pounds per foot on the whale, and my wall ties, if you read the beginning, has a maximum load of 3,000 pounds, I can determine the spacing of the wall ties by dividing what one wall tie can handle divided by the amount of load per lineal foot. So wall tie spacing. That's the load a wall tie can handle. That was given. This is the biggest number I've got on my chart. If I divide those two, I'm going to find out how many feet apart I can put those wall ties. 3,000. 3 grand divided by 1406.25. 2.13 feet. So every a little over 2 feet, I could put a wall tie. And if you look at your handout, they ended up using a 24-inch spacing. So every 24 inches, there would be a wall tie going. So every 24 inches, I'd have a tie going right through there, tying to the other side of the form. So every 24 inches along the wales, they don't go through the stud. They go through the plywood right near the stud. So every 24 inches, I'd have one of those, which means that the wale is supported at every 2 feet. So every 2 foot, so if I looked at it from the top, there's my wale going across. It's running out of juice here, more than one way. Every 24 inches, I'm going to have a wall tie. So the wale is supported by the wall tie. So the span of the wale is between the wall ties. So my spacing is 2 foot. So your book used, that handout used 24-inch center to center wall tie spacing. Okay, now I got my spacing. So these guys are per drawing. Okay, 12 inches, 27, and so on. And the guys going through here are at 24-inch center to center. Okay, so now we're going to check the wales and make sure they're okay. Once we get done checking the wales, we're done. And now all we got to worry about is the wind pushing us around. So let's go and do the wale itself. So the wales are at 24-inch centers, spacing as support-wise. So we're going to check the wale size. Check wale size. I'm going to put wall ties, 24-inch center to center. Okay, so we're right now at the very bottom of page 612, left-hand column. So we want to check the bending and check the shear for the wall tie. Okay, if I do that, assuming a 3,000-pound load on the ties are to be used, the spacing will be determined as noted in step 5, which we already did, is 2 foot. And they said here, we're going to try. They don't tell you this, and I don't know why they don't tell you it, but they don't. Unless they did above, I don't see it anywhere. Okay, they say that we're going to be using 2 2x6s for our wale. So these guys right here are 2x6s. Okay? And they want me to check and make sure that everything is okay. So the section modulus required, bending. Now these are another set of equations. They mimic what we've got, but they're in different format. So we're going to check bending and we're going to check shear. So the bending equation, S is equal to and the shear equation hopefully you see that has a lot of similarity to that. Okay, we're going to check and see what the section modulus works, and if it works, we're going to check and make sure that it doesn't exceed the shear. So how do we do this? Okay, this is the spacing of the wall tie. So, man, I'm running out of wall tie spacing. In our case, 24 inches squared. Okay? And the other one is the same thing. This is the wall tie spacing. It's a big L. Okay? 2 feet. Okay, we got B and H, that's the size. We don't need that. Looks like if I've got F and W, and we were using the same wood, okay? So the F should be the same as the last one, which is at 1313. So go back to the last one. We're using the same wood for the wales as we use for the studs. So that's good. And the W, what was our worst case? Hopefully you got that in your notes. I erased it, unfortunately. It was right here. Our worst case load on our whale was what? Right here? 1406.25. 1406.25 pounds per foot. So that's off of your loading diagram.